Here we have a square inscribed in a circle, and we want to find the location of these points in the circle. Okay, and we know that if we draw a line to that point references a 45-degree standard position angle. So we know that this triangle here is a 45-degree triangle, and in this case the radius is 1. So we need to compare that triangle with the special triangle, which has 1, 1, root 2. Okay, and we can work out the x coordinate and the y coordinate by relating it to this triangle. Now we can use a trig ratio, so we can say, for example, the cosine of 45 degrees is equal to x over 1, which is equal to 1 over root 2. And we don't need a calculator for this because we know the exact ratio here. So now once we get the exact ratio, we can solve for x as a proportion, and we get x is equal to 1 over root 2. So this length here is 1 over root 2. The y length, well, since it's symmetrical, we can say that it's 1 over root 2, or we can use Pythagoras, or we can use sine to figure this out. But either way, we can find the exact value of those lengths. Okay, so this coordinate here works out to be positive 1 over root 2, positive 1 over root 2. The one in quadrant 2 then, well, it's going to go the same distance, but it's going to go backwards 1 over root 2 in the x direction and positive 1 over root 2 in the y direction. This coordinate down here is negative 1 over root 2, negative 1 over root 2, and this one becomes positive 1 over root 2 because it's going to the right. It's still going down from the x-axis, so it's going to be negative 1 over root 2. So we have the exact values of all four coordinates. For this one here, we have a radius 2 circle, and we want to find the positions of these 3 points, the vertices. The first one's really easy, because if I take a look at where it is on the coordinate axis, it's going to be 0 to the right, and it's going to be up. Well, in this case, the radius is 2, so it's going to be 0 and 2. So then we need to figure out the coordinates of these 2 points here. Now to do that, we need to figure out the x position and the y position, and we can use our triangle to do that. What we know about this triangle is that length is 2, and then we got to figure out the vertical and horizontal lengths. Well, if I take a look at that triangle, I know that's a 30-60 triangle. I know my horizontal length is a long length, my vertical length is a short length. I can reference this triangle. It's going to be root 3, 1, and the long side is 2. Well, that's all works out the same, except now that I got to make sure that my positioning is correct, because I got to go to the left and I have to go down. So the coordinates are going to be negative root 3 and negative 1. So there's 2 parts to this. I need to know the triangle, okay, to get the lengths, but I also need to make sure I get the right position. So I need to make sure I go to either to the right or left. I need to make sure I'm indicating positive or negative, up or down. So again, I need to indicate positive or negative. So once I have that point, well, I know that this point over here is really the same. It's just symmetrical. So I'm going to go positive root 3 this time, and I still need to go down 1 to get to that point. So those are my exact value coordinates for all 3 vertices. So we are expected to be able to solve these special angle problems without the use of a calculator. So notice that I got angles without a calculator. Even if we want to describe this angle here, from here to here, we know the shape of this, and we know the angle that goes with that shape. That's going to be 210 degrees. We did not use a calculator to get that 210 degrees. We just get it directly from the shape.